So now I have to show you where all this stuff is, and let me go to the SSEP website. We go to the home page, and now I'm going to share my screen. And so the first thing that I need to reinforce here is that everything that I've said today is on the website, right? And you have this library of videos that are chunked into, different sections where you can go right to say, how do I get started with, how do I figure out what kind of experiment I want? And you can go to that video and see the 5 different ways that you can think about coming up with an experiment. So everybody see the website, is that correct? Okay.
Yes.
So this is the main SSEP website. The way that you can tell is that there is an International Space Station against a black sky in the big banner. And what you'll notice on this home page is 2 rows of navigation buttons. And I'm going to blow off the second row right away for you. You don't have to do anything with the second row. Your job is coming up to speed on the microgravity curriculum, designing your science experiments, and writing proposals. And none of the buttons on the lower row have anything to do with that. Now, just for completeness, let me tell you what's on the lower row. If you want to read over 1,500 media articles that we know of written about this program so far, you can go to In the News and you can read every one of those 1,500 plus mission by mission. You can read about our strategic partners. You can read about our national partners. You can read a bio of every Step 2 national review board that is ever my internet connection is good. Okay, well, it says it's on.
I think you're coming back now. It was a bit robotic there for a moment.
Yeah, it looks like, I was looking. Okay, so you can go and read all of the review board bios that selected flight experiments. And the first, if I hover over review board's main page and I click on the first tab, what you'll see here is a page called Getting Guidance for Setting Up a Step 1 Review Board in Your Community. So this is for your community program directors on how to set up your review board. And then you can download logos and banners, and you can go to our main organizational website or our international website to see what other things we're doing. But none of that has any bearing on what you're charged with doing in terms of experiment design and proposal writing. So you can blow off half the content of this website. Everybody with me on that? Okay, so now I'm going to go across the top row. And the top row is divided into, it has 3 different segments. You might want to copy this down. The first 2 buttons are one segment. The next 4 buttons are another segment. And then there's the last 2 buttons. So 2, 4, and 2. What do I mean by a segment? Well, the first thing out of the gate is once you're done with this video conference, the first thing you do is read the home page. And the reason for that is that the home page is what's called an executive summary of the program. So it's a really good summary of SSEP. And then you read the More on SSEP page. So if I click on that, it even says More on SSEP, a deeper dive. So now it goes deeper than the summary on the home page, and it puts flesh on the bones. So when you read the home page and the More on SSEP page, you have now gotten a reinforcement of everything I said early on in this video conference on how this program works. And once you've done a review of the homepage and the More on SSEP page, you don't need to go back to them again. You now know how this program works. It's only done at program start. The next 4 buttons, Flight Opportunities, Teacher Resources, Contact, and Community Network website, are the 4 buttons that you're going to use on a daily basis through this program. That's where the curriculum is housed. And then you've got the last 2 buttons, which are interesting because if you want to read prior blog posts on the SSEP blog, you can do it here. And if you difference button, go to say to space. So I need the out the experience the participation that 6 minutes long plus 2 minutes of Q&A. And so the blog and the conference are useful operations. So does everybody understand the first two for reinforcements are useful, but then you're not going to use them on a regular basis? Everybody with me on that? Okay, so now there are two flavors of curricular resources. There are web pages and there are documents that are downloadable in the document library. So the first thing I'm going to do is hover over flight opportunities, and you'll notice multiple missions listed here. All of them are ongoing right now in different phases of their life cycle, but your mission 21. So if I hover over flight opportunities, I see there's a mission 21 main page and 3 subpages over here. So these 4 mission 21 pages are part of your curriculum. The main page provides you an understanding, I hope it goes there, yes, of what the spacecraft is that's going to take the experiment to space, what's going to bring it back, how many experiments are part of mission 21, and the launch date. And what you see here, a lot of red TBDs, which stands for to be done, determined, because we don't know that information yet. So as we get that information, we will populate this page. But under flight opportunities, mission 21 main page, if we hover there, we can go to the critical timeline page. And this is what I promised. It's a bulleted list of all the milestone dates and deadlines from the start of the program through the return of the experiment to your flight team for harvesting and analysis. If we go to flight opportunities, mission 21, and then we go to the Minilab operations page, this is the operating manual for the Minilab, and it tells you the mission 21 operations page is still under development. We're working on it right now because we just switched over to the Rhodium Minilab, which operates pretty much the same way. It's virtually the same capability as the NanoRacks Minilab. So for right this minute, we're saying go to the mission 20 Minilab operations page, which overviews the NanoRacks Minilab. And what you'll see here, let me just kind of run down this. There are 3 modes of operation. There's a single tube, one volume with no clamps, 2 volumes with 1 clamp, 3 volumes with 2 clamps. And what you have here is examples of experiments that are well suited to each of those 3 configurations. And then the next part says, you're getting the flight hardware. You're getting the hardware that's going to be flying in space. You're going to fill it, seal it, ship the Minilab to Houston. You're going to get it back. You're going to do the harvesting yourself, real flight hardware. The next part is that there are 5 crew interaction days. There are only 5 days that you can ask the astronauts over that 4 to 6 week period to do something. On arrival, the day of arrival, 2 days after arrival, 14 days after undock, 5 days after undock, and 2 days after undock. And so you have to work on a delta T for your experiment that fits these 5 crew interaction days. The next section tells you what you can ask the astronauts to do and what you cannot ask the astronauts to do. The next section provides you the volumes and the dimensions of the Minilab. So if you want to do trial experiments before submitting your proposal and put trial data in the proposal, you can do the experiment in test tubes of the same volume, the same volumes. Here it tells you what you can fly and what you cannot fly. If you want to fly radioactive material, we got a problem with that. If you want to fly concentrated sulfuric acid, we got a problem with that. If you want to fly biologicals that have a biosafety level 2 or higher, that's not going to happen. And in fact, the Minilab is made up of materials like silicone. And there are fluids and solids that adversely interact with silicone. Worst case, they dissolve silicone, which means that if the Minilab fails, the fluids and solids are entered into the crew cabin that can pose a risk to the astronauts and the vehicles. So you need to understand what you're not allowed to fly. And there's something called the problematic samples list in the document library that is the no-no list. It tells you you can't fly human samples because you need hepatitis A testing and and HIV testing, and that's just too much of an investment of experimental review. Then there is the constraints on the flight timeline itself. You've got to turn your mini lab in 2.5 weeks before launch. The launch could be delayed. It'll take a few days to get back. And so likely it says in conclusions here, you likely need to put the experiment up in an inactive state to be activated by the astronauts and deactivated before deorbit, which is why most of the experiments, 75%, are biological in nature. I'm just telling you what I told you already. I'm just showing you on the page. And then you probably want to know what the temperature is along those different legs, from your institution to Houston, in storage in Houston by rhodium, the temperature going up to the International Space Station, the temperature on space station, the temperature back on the rocket, the temperature back to your community. So all of these are the constraints on experiment design, and you all need to know this page backwards and forwards before you start designing your experiment. Does everybody understand what's here?
I have a question from UCF.
Yep.
The mini lab page is password protected, presuming this information will come to us once the page is ready. Is that correct?
You already have the password information for the document library and the mini lab operations page. On Wednesday, one day after program start, we sent 3 of 4 program start emails to your community program directors with which stated that this needs to be timely reviewed and passed on as appropriate. And program start email number 1 provides you an understanding of the 2 websites, the starting place, and it has all of the passwords and user IDs. So your community's got that 3 days ago. So you need to get those from your community program directors. And now if we go to the teacher resources button and hover over it, you see there's the teacher resources main page and 5 sub pages. So these 6 pages are also part of your curriculum. And that now includes the Mission 21 main page under flight opportunities, and the critical timeline and mini lab operations page. By the way, I didn't say there's a 3rd page here. The Mission Patch Art and Design competition page for Mission 21 is for all the art and design and even history teachers that are going to be conducting the mission patch portion of this program. So there's no reason for us to go into that now with you all. But under teacher resources, you've got these 5 sub pages. And so you have the flight experiment design competition page, the designing the flight experiment page, the document library, the 2 teachers how to move forward page, and a really robust FAQ. The teacher resources main page is your main resource summary. It provides an overview of all the resources that you're going to use. And I'm going to go to that teacher resources page right now. Actually, before I go there, let me also take you to the 3rd button, the contact button, which is important because I said early on, we have your back. If you or a faculty member has a question, you can submit it via the contact button, and it'll go to the whole flight operations team, and they'll know who to answer, who's going to answer that question. So if I go back to teacher resources, you'll now see why I just talked about the contact button. I click on the teacher resources main page, and here is a summary of all your resources. And so the first section says technical assistance. If you have a question, we can help answer it. Use the contact button. That's the first section on this page. The next section says this website. And what we've done here is gather all of the web pages portion of the curriculum in one place. It's a summary of all the web pages portion of the curriculum. So here is a summary of the flight experiment design competition page, which provides an overview of how the competition works. Here is the designing the flight experiment page. And this is a really important page because here is where you're going to see an understanding of classic experiment design and how to keep the variables constant and change one. And it all starts with an essential question. And it talks about a microgravity experiment as a special case of experiment design where you're trying to understand the role of gravity in something. It takes you to the top of Jeff's mountain. It takes you into the elevator. It shows you the ping pong balls. It's all there on the Designing the Flight Experiment page. And then you see the Mission 21 main page, the critical timeline page, and the mini laboratory operations page. So all of the website flavor of the curriculum is summarized here, and you don't care about Mission 20 or Mission 19. Does everybody understand what I just did in section 2? Okay. In section 3, it's a summary of the document library and where the documents that are downloadable are housed. And then there is a link to that. And then there's the Two Teachers How to Move Forward page, which is really important, and a link to that, and an FAQ and a link to that. So when you see this, you can see the website pages linked here. You can see the document library, the Two Teachers How to Move Forward page, and the FAQ. And you can go to those subpages from this main page, or there's another way to do it. If you hover over Teacher Resources, you can see the Flight Experiment Design Competition page, the Designing the Flight Experiment page, the document library, the Two Teachers How to Move Forward page, and the FAQ. Everybody see that navigation? Okay, so now what I'm going to do is I'm going to skip the document library for a moment and go right to Two Teachers How to Move Forward, because now you see that the curriculum has a bunch of different components. And one problem is that, okay, I know where these components are, but what is the order in which I do this stuff? What comes first in this program? What comes second? What is the logical order in which I go through the program from program start to program finish? I need a recipe. I need a bulleted recipe for how to move through this. So like, it's sort of like a technician, right? In that mode, you're in technician mode walking through the program. That's what the Two Teachers How to Move Forward page does. And so I'm going there now. And it says in the very beginning, under navigating this website, the experiment design information, the first thing it says in the first paragraph, the first thing you do is read the home page and more on SSEP page to reinforce an understanding of this program. And then in purple text, it says, however, teachers need to concentrate on getting students moving on experiment design. So here is the key. All the information that specifically addresses the design of student experiments are all accessed through a careful read of the teacher and student resources page, the link labeled teacher resources in the top navigation banner. Think of that page as your Grand Central Station for SSEP experiment design in the classroom. One of its subpages is the page you are reading now. So it's walking you through everything. It's saying this teacher resources main page is the starting point, and then you have all these subpages, and one of them is the Two Teachers How to Move Forward page that you're reading now. And so now there's a section called the Proposed List of Tasks and Activities for SSEP Launch provided in a reasonable order. So the first thing it says is go to the Teachers and Student Resources page and explore all the links. Go to the Flight Experiment Design Competition page, go into the Designing the Flight Experiment page, and it walks you through the entire program bullet by bullet in chronological order. And every time there is a web page flavor of the curriculum, there's a hot link. And every time there's a document in the document library, like the microgravity science background document, there's a hot link to the document library. So does everybody understand how this page walks you through the curriculum? And on the bottom, there is important advice to teachers, which is advice to you because you're your own teacher at the undergraduate level. And I want to pay particular attention to section 3, which says we are urging all student teams to reach out to national researchers using Google Scholar Search. So if your faculty advisor is not an expert in your experiment, you need a researcher advisor. And if your faculty advisor can't suggest somebody to reach out to, use Google Scholar Search. And here you have the link to Google Scholar Search. And here is an example of how the researcher advisor for the planaria worm regeneration team saved the experiment, because there was an important question that the team asked the researcher advisor, and they said, how do the planarium worms survive to get to orbit? Do we feed them? And the researcher advisor said, no, you starve them because they will go into a state of hibernation. And that's what saved the program. That's what saved their experiment. So does everybody understand this page now? Now, if we go to the document library, let me walk you through this. So we are now in the process of updating the documents from mission 20 to mission 21. Those documents that are still in red are still mission 20 documents. And we are updating that, right now, early next week, they're going to be updated. But let me tell you what these documents are. And the updates, by the way, are minimal. So it's not, except for the proposal guide where we have to put in new graphics for the Rhodium mini lab as opposed to the Nanorex mini lab. And our senior flight operations manager is working on that. So section 1 is general program overview document. So if you want to download a 3-page overview of mission 21 at a glance, you can do that. You can download our congressional briefing document that we leave behind on Capitol Hill when we brief congressional staffers. But that document concentrates on strategic STEM strategic STEM objectives of this program. You can watch video overviews of this program. You can download or you can read a feature article in Scientific American Frontiers called Not Your Grandma's Science Competition. You can download a PowerPoint of Mission 21. It's a great presentation medium where if you want to get other students excited, you can. If you want to present to the other campuses what you're doing, there is a PowerPoint on Mission 21. And then you get to the Student Proposers Resource Library. The first one is called Two Students Getting Started with Experiment Design, which is what it sounds like. Here is the microgravity science background document that provides an overview of 9 separate science disciplines appropriate for microgravity research and the accompanying case studies document, a place to get ideas. Here is a document that allows you to understand how to shut down biological experiments using fixatives like glutaraldehyde and formaldehyde. So that's an important document. Here is the master list of experiment samples with hundreds of fluids and solids that are typically used in microgravity experiment design, so you can get ideas for an experiment there. And this is the problematic samples list. This is the no-no list, which has a list of fluids and solids that can adversely interact with the materials making up the mini lab. And so you do not want to use these fluids and solids. So when you come up with an experiment, one thing that you do early on is you come up with the fluids and solids that you're proposing in your experiment, and you check against the no-no list because you don't want to use anything on the no-no list, and you see if you can come up with something different. Here is the flight experiment proposal guide itself, which is the template for a proposal. There is a background for teachers document that goes with the proposal guide, which is for you because you're your own teachers. There is a background for student proposers, which is for you because you're the students in this program as well. And then I can tell you that the proposal evaluation rubric that is being used to grade the proposals are in both of these background guides. And then for the flight team, the toxicologists at Johnson Space Center are going to need they're going to need specificity with regard to your fluids and solids. They're going to need the origin of the fluids and solids, where you got them, and they're going to need safety data sheets on the fluids and solids. So that's for your flight team. So does everybody understand what's in the document library? Okay, and now the last bullet, the last button that we haven't gone to is the Community Network website. And if I click on that, it'll say you're about to leave the main SSCP website and go to a completely different website called the SSCP Community Network Hub site. And if you click on that, you're now at a different website. And the way you know is that the banner has changed from Space Shuttle Endeavour to a blue Earth. And this website is dedicated to all the communities that have ever participated in the program. The website we came from, the main site, has all the resources to do the program. And if you drop down here, you'll see a map of the world. And if I slide the map over, you say that Ukraine is participating in their 5th flight opportunity. They started before the war erupted in Ukraine. They have 1,000 students engaged in this program across Ukraine, but many of those students are displaced to Germany, Czechoslovakia, Poland, and how they're continuing to do this program is remarkable. And the Ukrainian Junior Academy of Sciences, we met with the Ukrainian ambassador to the United States at the embassy in Georgetown, and the ambassador said to the student teams coming in for the flight, for the launch of their first experiment, that your job as students is to inspire students across Ukraine in what is possible for the next generation despite the war. So you got to kind of let that sink in, because I don't want to hear from American students anymore how hard things are in education to do things when I know what the Ukrainian students are going through. And if I click on this plus sign down here, you can see mission by mission, all of the communities that have ever participated. And all of the communities in green are communities that have participated more than once. Hillsborough County, which is kind of close to you, for mission 19 was on their 12th mission. They have a space program they do with SSEP every year. And then if you go to communities and local partners and you click on, say, mission 19, you can see all of the communities that participated in mission 19. And if you scroll down to, I don't know, let's say we go to Athens, Ohio, what you'll see is that Athens, Ohio, it is the Ohio University that's conducting the program. And it tells you that for the mission patch competition, they engaged all of these elementary and middle school students. They had 50 undergraduates participating in experiment design, 10 proposals, 2 competitions for the mission patch grade K through 4, 5 through 8, the partner institutions with links to them, their community program directors with email addresses. And here you can read a community profile for over 400 community programs that have been done through SSEP since program inception. If you go to experiments selected for flight and you go to, say, mission 19, you'll see all of the communities listed for mission 19. And if I drop down to, say, Colorado Springs, Colorado, we see that it is the University of Colorado, Colorado Springs that's participating. And here is a summary of their flight experiment with their PI and the COI student investigators. And it's fungal bioleaching and microgravity, fungal approaches to metal recovery. And mission by mission, you can read over 400 summaries of flight experiments right here. And under the community profiles and local partners button, the first button is an overview of all the undergraduate participation to date. And as you go from institution to institution, it provides an overview of their strategic objectives and why they're doing this program. And it also has a summary of all their flight experiments. So you can go just to this undergraduate page and read all of the experiments that have been done in SSEP at the undergraduate level. And then under mission patches, if I go to, say, mission 17, I can see all of the communities involved in the mission 17 mission patch art and design competitions, and all of the flight patches are listed here. And if I click on a patch, I can see it up close and personal. And under each community set of patches is a description of how they conducted their mission patch art and design competition. And Pendergast Elementary School District had 1,774 grade K through 5 students engaged and 1,542 grade 5 through 8 students engaged across 4 schools. And so you could engage thousands of students in this program if you want to. And then if you go to scientific return and reporting and you go to, say, mission 13, you can watch a video of every PowerPoint oral presentation conducted by student teams at the conference for mission 13. And you see that they're under this gray kind of mottled shaped thing. And the reason for that is that that particular conference, many of the conferences are held at the National Air and Space Museum's Udvar Hazy Center, and the conference is held under Space Shuttle Discovery, the real Space Shuttle Discovery. that launched the Hubble Space Telescope. And here you see a team presenting under the aft portion of the shuttle. And what you're seeing above them in gray are the borosilicate glass thermal protection system tiles of the space shuttle's underbelly. So does everybody understand the power of this other website to allow you to see what the other communities have done? Does that all make sense? And so what I want to do is leave you with one last, actually, let me share this thing to see if there are any questions. Hang on a second. What I want to do is I want to go back to the main website, and I can click on this little banner here. I can click on this button that says main website. And I want to take you to the first, actually not that one. That is the SSEP website, the SSEP main website. Okay. I want to take you to the flight opportunities button again. And the first bullet, the first subpage is called the Launch and On-Orbit Operations History page. If I click on that, what I'm going to see is a launch of a rocket carrying an SSEP payload of experiments. And underneath that launch, this is mission 18, are the two astronauts that were part of SSEP that operated the mission 18 experiments. And you might recognize Sunita Williams and Butch Wilmore's names because they are senior astronauts for NASA. They piloted the Boeing Dreamliner last year to ISS. And because of Dreamliner failure, they were left on station for 9 months longer than they were supposed to be. They're part of SSEP. And next to the astronaut is a link to their biography and their social media accounts. And then we can go and take a look for mission 17 and mission 16 and 15 and 14. And we can keep going down, looking at the remarkable history of this program until we go all the way down to the bottom, because the first SSE payload was on the final flight of Space Shuttle Endeavour, STS-134. And the second payload was on the final flight of Space Shuttle Atlantis, which is STS-135. It is now on display at Kennedy Space Center. And this was the final flight of the US Space Shuttle program. And we were the only payload on the first SpaceX demonstration flight. And we were on the first operational flight for SpaceX, the first demonstration flight for Cygnus, the first operational flight for Cygnus. And so this program is America's space program. And what I said before is exactly right. We are welcoming all of you into America's space program in every sense of the word. I am finally done. Anybody have any questions, comments, thoughts?
I have a question. I don't know. Can you see me? Hello, I'm here.
I can see you waving.
I think I understand well the overall design of the mini lab on the ISS. I'm more curious about the control. Is there a common place that mimics the environment in the ISS except for the lack of gravity? Oh, except for having gravity?
So there's no.
So we are going to send the samples, or we need to do that ourselves?
Yeah, so you need to, and that could be, for instance, an engineering task if you feel that that's appropriate. But the whole idea is that you want to keep all of the variables constant as much as you can, and change the gravity variable. And so that's why, for instance, when you go to the mini lab operations page, you'll see that the temperature on ISS is in the shirt sleeve environment between 70 and 75 degrees Fahrenheit. The mini labs are in an opaque payload box. So there's no light source around the, for these mini laboratories. And you don't want that. You don't want a mini lab that is designed for darkness to be exposed to light and vice versa. So you have to design all of the experiments to the same engineering constraints. There are about 7 mini labs in a payload box. So once you understand the environment in which it operates on the International Space Station, you want to simulate that environment on the ground. Does that answer your question?
Yeah, I was just thinking you guys should in the future maybe have a place that already mimics, and then we can just send the samples there, no? Like for the control?
So would you send your students there?
Yeah, maybe. Oh, I see. Yeah, because of,
So if you're in
Shoot.
Ukraine, you're going to pay, I don't know how much to send your students to this facility.
I see. Okay, so
And-
we are responsible in our own facilities to mimic that environment.
Yeah,
That's-
and let me say something else. Let's say we rent space to create such a facility. That cost, and I assume we're gonna have to have staff at that facility when the ground control experiment is done. And the ground control experiment is done for 4 to 6 weeks on orbit, and the crew interactions have to be mimicked. So we're gonna have to pass the cost of the staffing and the space onto you, which is gonna dramatically increase the cost of this program. So, you know, the business model is always a compromise. And what you're suggesting is beyond a reasonable business model, because if I tell you that this program is not $26,000, but it's $40,000, and by the way, you have to pay for your student teams and your entire student team's travel to this facility, so that's more thousands of dollars in room and board so that your students can be there for 4 to 6 weeks. It's not real world.
Yeah, makes sense. Okay, thank you.
Yeah. Any other I mean, it sounds a little harsh, but I just kind of want to, you know, as the program's creator and director, when you ask that, my wheels start turning in lots of different directions, because I also have to make sure that there's a viable business model for the organization.
Yeah, so in the, I imagine like all the environmental variables in the ISS are described well there in the documents, right? So we can follow that. So that'll be fine.
Well, so as an example, there is a radiation environment on ISS that's different here on Earth, right? And so the astronauts, their exposure to radiation is limited. Their lifetime exposure to radiation is limited. After they hit that limit, they can't be astronauts anymore. There's no way for you to create the radiation environment that's on the International Space Station, nor would you want to. And so when you're looking at these experiments, you're looking at you're looking at the gravity variable role in this, but there are other things that you should think about in terms of environment. The other piece that's really important here that you need to consider is that launch and re-entry are violent. They're violent events. There's a lot of shaking. There's no way to characterize that shaking in your ground control experiment. And so you need to recognize that, as in the case of experimental design in general, there are some variables you simply cannot control.
Here's a question, if you can hear me.
Yes,
Yeah, I just want to clarify this. You mentioned there'll be 5, other than the trial tubes, there will be 5 tubes to provide the 2 for safety, 2 for the optimization, 1 going to the flight. I just want to make sure that's exactly what we have, or the possibly more than 1 tube, more than like 2 or 3 tubes, just in case we need to compare or taking multiple data points that with multiple tubes, like 2 or 3 tubes, allow go to the flight, or
so are you saying that you want to fly a second tube?
yeah.
Yeah, so you got to pay for that flight slot.
Okay.
Right? So I can tell you that if you want an additional flight slot, you've got to accelerate twice the experimental equipment to 18,000 miles an hour and take it 250 miles above the surface of the Earth. That, by the way, is another $16,000. So if you have a total of $42,000, you can fly 2 tubes, but every additional tube is $16K. So I could tell you that we have never had an undergraduate team fly 2 tubes. Right? So, you know, the way to think about this is you can't isolate the experiment design thinking from the cost involved in doing that experiment. Just, you know, there was somebody, a professor at one university, who said, "Oh, yes, I'd like my students to work on the detection of gravity, and we want to send up an 80 kilogram mass to measure the force of gravity in space." And I'm going, okay, let me calculate what the cost of putting up an 80 kilogram mass is. It's probably, you know, hundreds of thousands of dollars. So that's the reality of spaceflight operations. That's, you know, we're constrained by the real world, is what I'm saying. Yes,
I
Justin.
got a question. So are there gonna be like recordings of the experiment while it's in space, or is it just like once it comes back down, that's when you can get like all the data and stuff?
Yeah. So let me address this, and let me see if I can work through the numbers in my head, but slow enough so that, you know, you can process what I'm saying. So the astronauts are paid a salary, but it also costs $55 million to get them there and bring them back on SpaceX Crew Dragon. Obviously, their salary is nothing compared to the $55 million cost. Let's say it's $50 million, not 55, but $50 million to get them there and bring them back. Now, there's a term that's used at the undergraduate, well, you know, your business office uses a term called FTE. It stands for full-time equivalent. You can ask, what is the full-time number of hours in a work year? And it's 2080, right? 2080, but you have vacation time in there too. So let's say it's 2,000 hours, okay? 2,000 hours. So let's say an astronaut is up there for an entire year, right? And works a full-time job, 2,000 hours. And it costs them it costs NASA $50 million to get them there. So what is the cost in astronaut time per hour? So that's $50 million divided by 2,000 hours. That's 50 times 10 to the 6th divided by 2 times 10 to the 3rd is 25 times 10 to the 3rd. So 1 hour of astronaut time is $25,000. And if the astronaut is only up there for 6 months, which is more consistent with astronaut time on station, it's $50,000 an hour. The astronaut's time is absolutely choreographed in advance. Everything is choreographed. The astronaut has 2 minutes to operate, the maximum of 2 minutes to operate each SSEP experiment on each crew interaction day. So worst case, if we have 30 experiments up there, 1 hour of their time can be dedicated to a single crew interaction day. That's enormously expensive. They only have 2 minutes. If you want to ask them to record something, that's time. If you want to have them set up a video taping of the experiment, that's additional time. And so the end result is you cannot ask the astronauts to do anything other than the well-defined interactions that are listed on the Minilab operations page. So they can combine fluids and solids, they can shake it if you want them to shake it, and then it comes back to you and you have to do the harvesting and analysis, and you only have a limited amount of time, crew time, to do these things. And even in those restrictions, there are incredibly powerful SSEP experiments that have been put together on the undergraduate level. And so on the Minilab operations page, it tells you specifically what you cannot ask an astronaut to do. So Justin, again, it's a tough question to answer, but I need to give you the real world, you know, playground in which we have to operate. Yes, Cody.
So I guess this one's a bit more general. I know we went over the no list of materials following the rubric, etc. But are there any like common pitfalls or challenges that teams have faced in previous SSEP experiments, and how do you think we could avoid falling in
Yeah,
those
so
pitfalls?
that's a good question. So one thing that I think is important is that if you're doing biologicals, you need to figure out typically how to sterilize not only the mini lab but the biologicals. And in fact, biologicals can be secured in a sterilized form. But you don't want things like mold and fungi going along for the ride. And so in fact, there is a section on the mini lab operations page talking about how to sterilize. So that's something that's really important. We've had experiments that have failed because they weren't sterilized, and the biologicals come back as a goo because of contamination. Another thing that has happened is the launch could be delayed for a long time. In other words, like weeks, many weeks. Let's say the spacecraft, the vehicle, they're testing it out and they find out that one of the main engines has a red flag, that there's something wrong with the main engine, and they have to bring the vehicle back to the shop and change out the main engine. Well, you might have a perishable experiment. You might have a perishable experiment, which means that we have to refresh your experiment. You have to send yet another experiment to take the place of the one that is no longer viable. And that's why we reserve for each community 2 additional flight certified mini labs in case a refresh is needed. And we learned the hard way not to give those 2 mini labs to the community and tell them, put them in a safe because this is for refresh, because somebody didn't follow those directions in the community and they used those 2 mini labs for ground control, additional ground control, or optimization of the experiment. And that team did not have a refresh mini lab available. And so, does that kind of give you a sense of like 2 examples?
Absolutely. Thank you.
Right. But that's a really good question because it probes deeper.
Jeff, UCF wanted to thank you. They said it's been extremely informative and they're excited to get started.
That's what it's all about. That's what it's all about. We're here for you. Welcome to America's Space Program. Have fun with this, be inspired by it, and figure out how you can leverage this into something bigger in terms of a career. So if there are no more questions, I just want to wish you a happy Friday evening, a wonderful weekend, and get started with experiment design.
Thank you,
Thank
Dr.
you.
Goldstein.
Thank you, Jeff. Have a good one.
Very welcome. Take care.